Okay, there we go. Well, I hadn't started it yet. That was the problem. Okay, so for this row, okay, we are raising powers to powers. In addition to that, there are multiple things that are being raised to the power. So if I have x, y squared, what two things get squared? X and y. Both get squared, okay? So if we're doing something like this, all three terms in there have to get raised to the power of 5. But what do I do when I raise a power to a power? Multiply. So here we're going to have 2 to the 5th power, x squared to the 5th power, and z to the 5th power. Okay, so from here, what is 2 to the 5th power? What was that? 32. Okay. What do you get when you raise x squared to the power of 5? You get x to the... Okay, and then z will be z to the power of 5. There wasn't anything else for us to do. All right, then we are going to look at question 5. Okay, so for here, everything is getting raised to the power of 3. So we're going to do x squared to the 3rd power, y to the 3rd power. So we multiply those exponents. We're going to get x to the... Yep. All right, now we're going to look at the 3rd row. Stop talking. Okay, this is the row that quite possibly made me the most frustrated on your tests. Because you were given the rule on your notes explicitly. It said if you have x to the power of negative n, the answer was 1 over x to the n. Right? It told you that explicitly. Because whenever it is in the numerator, if it is a negative exponent in the numerator, it gets moved where? To the denominator. Okay? That is all you have to do. So what should this be? It should be 1 over x to the 3rd. Okay? Now, for number 8, if you have 1 over x to the negative n, and it's in the denominator with a negative exponent, where does it go? To the numerator, okay? And it becomes positive. So what should the answer to number 8 be? Y to the 3rd. Lots and lots of people miss those questions on the quiz. Okay, and they were quite possibly some of the easiest questions on the quiz. It made me really frustrated when people missed questions 1 through 4, but then got all the hard ones right. I was like, what do you mean? Those are the easier ones. So I want us to make sure we get those. Okay. Now for number 9, we have 2 parts we got to look at. So in the numerator, we currently have x to the negative 4th. Where does that need to move? Okay. And when it moves to the bottom, what does it become? X to the... There we go. And then we also have y to the negative 2 in the denominator. Where does that move? And it becomes y to the... There we go. Yes.
I just realized I changed the variable from y to x. And x
Lots of people did it. Lots of people did it. Lots of people did it. Yeah. And that was one of the things I was just like, okay, whatever. X, going about my life.
It's just,
It wasn't the right one. Yeah. Yeah. It's unfortunate. But, you know, we are going to learn from our mistakes. And we're going to do better next time. That's why I gave you the quizzes back. All right. For number 10. We're actually not going to do number 10. We're going to go to number 11. Okay, so for number 11, when we were dividing, okay, we need to look at our constants. So we have 9 divided by 3 is what?
3.
Okay, then we're going to look at y to the 7th divided by y to the negative 4th. When I divide two things with the same base, what do I do with the exponents? Subtract. So we're going to have y to the 7 minus negative 4. When you subtract a negative number, what do? You add. So what do we really have here? Yep, so it's going to be 3y to the 11th. All right, then we're going to look at number 12. Okay, so for number 12, let's look at our constants. We have 4 over 6. Can I divide 4 by 6? No, but can I simplify the fraction? What can I simplify 4 over 6 to? 2/3. All right, now we have x to the third divided by x squared. So it's going to be x to the, or 3 minus 2. Yeah, we subtract, which is 1. Okay, so it'll be x to the first. Now, we have y to the negative 2 divided by y to the third. So we should have y to the negative 2 minus 3. What is negative 2 minus 3? Okay, now, can I leave my answer like this? No. Our answer should never have negative exponents in them. So we have our fraction 2/3. Where will x to the first power go? Next to the 2. I thought you said x to the 2, and I was like, wait, no. Next to the 2. Okay, what about the y? Where does the y need to go? Yep. So we should have 2x divided by 3y to the 5th. And can I simplify this x over y?
No.
Why not?
They're not like, they don't have the same base.
They don't have the same base. They're not like. We can't do that. All right, now we're going to look at question number 13. So whenever we have a fraction, okay, if we have a fraction like x over y that is being raised to the second power, that is the same thing as us squaring the top and squaring the bottom. So all we have to do here is raise everything in the numerator to the power of 2 and the denominator to the power of 2. So let's start with the numerator. We're going to do 2 to the power of 2 to get this first term out of the way. Then we're going to do x squared to the power of 2. What is x squared to the power of 2? X to the 4th, because 2 times 2 is 4. Okay, then we're going to do y to the 3rd to the power of 2. What is that going to be?
6.
Because 3 times 2 is 6. Now we're going to move to our denominator. Okay, we're going to do z squared to the power of 2. What is that going to give us? Z to the 4th. Okay, and is there anything else I can simplify there?
No, 2 squared.
What is 2 squared? So we should have 4x to the 4th, y to the 6th, divided by z to the 4th. If there is a number you can write as a simpler without an exponent, write it. If there is something you can simplify, simplify it. If there's a negative exponent, write it so that it's positive. Okay? Now we're going to look at question 14. So for 14, we're just raising everything to the power of 3. So we have 3 squared, or not 3 squared, 3 to the 3rd power, and we have x to the 7th to the 3rd power. What is 3 to the 3rd power?
27.
3 times 3 is 9, times 3 is 27. But it will be x to the 21st power, because 7 times 3 is 21. Yep. Yep, there we go. Now, we're going to turn it to the back. Okay, 16, 17, and 18 are the easiest problems you could possibly have. What is anything to the 0 power? 1. So if we look at question 16, what is being raised to the 0 power? X. Is 2 being raised to the 0 power?
No.
So it's going to be 2 times, what is x to the 0 power? What is 2 times 1?
2.
And see, that's part of what was happening on our paper. We were just writing the first thing that popped into our head, and we weren't really thinking about it. We gotta watch that. It'll be okay. You just gotta watch it. Okay, first question 17. What is being raised to the 0 power? Okay, what is 100x to the 0 power?
100.
1.
It's just 1. So how is this one different than number 16?
It's 0. On 16, the 0 is only affecting the x one.
This one, the 0 is affecting everything, whereas here it's only affecting the x. Okay. For number 18, what is negative 20x to the negative 3rd to the 0 power?
1.
Here we go. All right.
Williams,
Yes, ma'am.
Jay is my Murphy dismissal.
Bye, Jasmine. The video will be uploaded by the end of the day. Okay. Now, we are going to switch gears and look at simplifying radicals. Okay. So if you have this symbol on your paper, what does that symbol mean?
Square root.
Square root. That means that it is understood to be a what right here? 2. When we are simplifying square roots, Do I need to look at the list of perfect squares or the list of perfect cubes? Ah, perfect squares. There we go. Now, for number 20, okay, is 28 a perfect square? No. What is the biggest perfect square that 28 is divisible by?
4.
4. Okay, so remember, to figure this out, okay, the number will not be bigger than 28, so we'll start with 25. Is 28 divisible by 25?
No.
No. Is 28 divisible by 16?
No.
Is 28 divisible by 9?
No.
Is 28 divisible by 4? Yes. Okay, so we'll break this up into the square root of 4 times what? 4 times what gives you 28?
7.
Okay, from here, what is the square root of 4?
2.
And can you take the square root of 7? So we just get 2 times the square root of 7. One of our problems was this, is that we were taking the square root, but when they took the square root, they would either forget to change the number or put it back under a square root, and we can't do that. Okay? Once you take the square root, the radical goes away. 421. What is the biggest perfect square that can go into 108? 36. 36 can go into it how many times?
3.
Okay? So we have the square root of 36 times the square root of 3. What is the square root of 36? 6. So we have 6 times the square root of 3. Don't be nice to each other.
He told me I
Put your
guessed.
feet down.
Oh,
He
sorry.
could have just said, oh, good job.
Okay. It's
Or
over
he didn't
now.
have to
It's
say
over now.
anything.
Okay.
All right, now we're going to look at question 22. Okay, so question 22 is still square roots, but we're also simplifying with variables. Okay, so if we have the square root of x to the third, okay, what is understood to be right here? 2. So to figure this out, is 3 divisible by 2?
Can I get Jagger McNeil up to the main office real quick?
Yes, ma'am. Okay, but can 2 go into 3? How many times can 2 go into 3? With how many left over? That is how we simplify these. Okay, so when we look at question 22, okay, this has 3 pieces that we're trying to take the square root of. So we're going to break it up. We're going to look at the square root of 98. We're going to look at the square root of x to the third. And we're going to look at the square root of y to the 7th. So what is the biggest perfect square that can go into 98? 49. 49 times what? What is the square root of 49? So we have 7 times the square root of 2. That's the first piece. Now, what is understood to be right here? 2. So is 3 divisible by 2? No. But how many times can 2 go into 3? With how many left over? Okay. So if you need to put the ones here and here, please put the ones there and there to help you out. All right, now, for the last piece. Is 7 divisible by 2? But how many times can 2 go into 7? 3 times. So we'll get y to the third with how many left over? All right, now we write our final answer. To write your final answer, what is outside the radicals will stay outside, and what is inside will stay inside. So what's going to go outside? Okay, then what's going to go inside our radical? 2x, 1, y. Okay, everything that's inside will be inside. Everything that is outside will be outside. Now we're going to look at question 23. Okay, so we're going to break this one up in pieces as well. So we're going to look at the square root of 64, the square root of x to the 4th, and the square root of z to the 3rd. What is the square root? Can I take the square root of 64?
Yeah.
What is it? Okay, that's the first piece. Okay, is 4 divisible by 2? Yes. Well, how many times can 2 go into 4? Is there anything left over? All right. Now, what about z? So, is 3 divisible by 2? No, but can 2 go into 3? How many times? With how many left over? So what is going to go outside of our radical?
8x minus x.
And inside is just c. There we go. Now we'll leave 24 to you. All right. Now we're going to switch gears to look at, oops, there went my phone. We're going to switch gears to look at cube roots, okay?
Although I don't have my phone, though, it's my computer.
Okay.
I'm being for real. No, I don't even know why the volume was on. I'm sorry.
Why don't you have your review in front of you with a pencil working on it? Thank you. Now, for number 25, all right, we're looking at perfect cubes. So, list of perfect cubes. What is the biggest perfect cube that 128 is divisible by? So, let's think. Is 128 divisible by 125?
64.
It is 64. How many times can 64 go into 128?
Twice.
So we're going to rewrite this as the cube root of 64 times the cube root of 2. What is the cube root of 64?
4.
So we have 4 times the cube root of 2. All right. Now we're going to look at 26. What is the biggest perfect cube that can go into 625?
125.
Oh.
125. Okay. 125 times what gives you 625?
5.
So what is the cube root of 125?
25. Or I don't know, 5.
5.
My fault.
I don't even go that far.
My fault.
Y'all are so mean to each other. All right, can I take the cube root of 5?
No.
Okay, so it's 5 times the cube root of 5. All right. Now, we are going to do cube roots with variables included. And we're going to go over 29 and 30. Okay, so for question 29, okay, we're going to break this into pieces. We have the cube root of 1,000. We have the cube root of x to the 4th. We have the cube root of y to the 3rd. And we have the cube root of z squared. So, what is the biggest perfect cube that can go into 1,000?
Oh, yeah.
1,000 is a perfect cube, so what is the cube root of 1,000?
10.
Okay. Now, is 4 divisible by 3?
No.
No. But 3 can go into 4
1.
with how much left over? Go. Okay, now, is 3 divisible by 3? So how many times can 3 go into 3? Is 2 divisible by 3? Can 3 go into 2?
No.
So we just get the cube root of z squared. So what is going to go outside of our radical? Yep, so 10xy. Then we're going to do the cube root of x times z squared. All right, for number 30, what is the biggest perfect cube that goes into 432? 216 times what? What is the cube root of 216? So we have 6 times the cube root of 2. Now we're going to look at the cube root of x to the 5th. Is 5 divisible by 3? But can 3 go into 5? How many times? With how many left over? Okay, then we have our last piece, which is the cube root of y to the 6th. Is 6 divisible by 3? How many times can 3 go into? Anything left over? So how would I write our answer? Times. Okay, another thing that caused minor problems on the quizzes that I counted off for is not including the cube. That and that are 2 vastly different questions. okay? You have to make sure you include that, okay? Now, we're going to flip and look at the last page. Okay, so for our last page, the first section is to rewrite as a rational exponent. So that is where we go from a radical to a fractional exponent. So when we have a radical, it'll be a to the m power, and then we're taking the nth root, okay? What we do to evaluate or to switch that to a rational exponent is your base is going to stay the same. So in this question, what is our base? A. And the power stays with it, but the root goes at the bottom like a tree. Okay, that is what we do for these. So if we look at 31, what is our base for question 31? 2x, okay? And it goes in parentheses. Now, what is the power? What's the root? There we go. That is how we rewrite that as a rational exponent. For the most part, we did okay on this. Yes, ma'am. Yes.
Wait, never mind. It says I got that one right.
Okay. Now, because once I got realized that I wasn't putting these tests in, or quizzes in, I was just doing it real fast, marking it. So if there was one that was a little wrong, that's probably why. But it's because I was like, there's not the point in me putting 1,000% effort into this when it's not going in the grade book.
Yeah.
It was mostly just so that y'all could see y'all's mistakes and learn from them and have a little bit extra practice for your test. All right. We're also going to do number 32, okay? For 32, what is our base? X. What's our power? And what's our root? Now, what is 8 divided by 4?
2.
That is x squared. Okay? Write it as simplified as you can. Now, we are going to go ahead and we are going to look real fast at 33. We're not going to do all of 33, but what is the understood power on 33? The understood root. That's my bad. But yeah, it is an understood root right there. Okay? Now we're going to rewrite using radicals. Okay? So this time, we're going to go from our rational exponent. So a to the power of m divided by n. When we rewrite to a radical, okay, our base stays in the house. The power goes to the house, but the trees stay outside. The root goes outside because it's a tree, right? Now, that's what we're doing for all of these. So, for number 34, what is being raised to the power of 2/7?
2x. No, 7x.
Okay? Is 3x being raised to the power of 2/7, or is x being raised to the power of 2? Just x. Okay? If this had parentheses around it, everything would be. But as it is, just x is being raised. So am I including 3 in my radical? So it's going to stay outside. And then I'm going to make my radical. What is the base of my radical going to be? X. What's the power? And what's the root? There we go. And would I have to put the root on that one? I could just write 3 times the square root of x to the 7th, because this is understood to be a 2 right there. All right, now we're going to look at question 35. What is being raised to the power of 7 over 3 and 35? 5x. Both of them are, right? So both of them will go underneath our square root, and they will be in parentheses still. Now, what is the power? 7. And what's the root? There we go. Now, the last section. Yes. Okay, what's your question?
34. I think we did that right. Does the 7 go on the inside
Ah!
or on the outside? Okay, I thought I was really. I tried to go ahead of you, and I was like, oh, I got this, and then you got to it.
I'm so sorry. What is the power there?
2.
2. What is the root?
7.
Yes, you were correct. Yes, I am so sorry. That was my bad. Just for that, we will do 36 together as well, just to make sure we've got it. Okay, for 36, okay, we write our radical. What's our base? What's our power?
3.
What is our root? There we go. That is how we do that. Yep. And you know, I heard when y'all said the power was 2, and I seen myself write 7. I went, that's not right. And then I just kept going. I don't know. But it's fine. See, that also happened to y'all in y'all's quizzes. Because I wholeheartedly think some of you knew it a lot better than you wrote it on the paper. You just, between this and this, something happened. All right, final section. Okay, final section. So with this section, it says simplify completely using exponent rules. Write your answer with a simplified radical. When it says write it with a simplified radical, that's only if it has a fractional exponent. Write it as a radical. So we're going to look at some of these. So for number 37, okay, we both have a base of y. What do I need to do with those exponents when I multiply? Add. So we have y to the 3 over 2 plus 7 over 2. So we get y to the 10 over 2, which gives us y to the 5th. Is there any point of me writing y to the 5th as a radical? No. Okay. If it's written like that, leave it like that. The only thing you have to write as a radical is those exponents that are fractional. Okay. Now, for number 38, okay, I'm raising a power to a power. So what do we do? Okay, so we have 4/3 times 2. What is technically underneath that 2? So if I multiply those together, I'm going to get x to the power of 8 over 3. Now, can I write that as a radical? Okay, our base is x, has a power of, and it's a cube root. Okay, but it says simplified radicals. Can I simplify that?
Yes.
How many times can 3 go into 8? With how many left over? So that's how we would write that. Okay, now we're going to drop down to question 40. Okay, for question 40, before I can do anything to this, I'm going to rewrite it as exponents. Okay, so our numerator is going to become what? Okay, what is our power? What is our root? So we get y to the 7 over 3. Okay, then we're going to rewrite our denominator. It will be y to the what? And when we have the same base and we're dividing, what do I do with exponents? So we will get y is equal to 7/3 minus 5/3. What is 7/3 minus 5/3? And then can I write that as a radical?
Yes.
Okay. What is the base of that radical? What's the power? What's the root? Can I simplify it? There we go. Because 3 can't go into 2. All right. There we go. Okay, that is our review. Okay, I want you to finish the review. It will be turned in the day of our test. Okay. The other half of our review will be done on Monday. We are playing exponential function Jeopardy. Okay, and with that, that is just participation points. Okay, so there won't be anything you have to turn in for that part of the review, but you do have to turn in this half of the review. Okay, if you want to go ahead and grab a note card for me and start working on that over the weekend, they are up here. You can grab one. You can use one 3x5 inch note card, front and back.